Okay, I've had a cup of coffee and I've done this previous lesson and I'm just doing this to help you with your homework. And I made about 10 mistakes at least yesterday. Let's see if I can get this right today on a video. And so what we did was we titrated oxalic acid with sodium hydroxide. And we ran out of time. We were doing everything properly and then we ran out of time and so we had to rush it and we overshot. And so we went for an average of 28 centimeters cubed of sodium hydroxide. All right, so tell me how many moles, what the moles of hydration are in the oxalic acid. I think I'm just, for speed, I'm just going to call that OX. All right, so I'm going to try to do this quickly, but I'm not going to edit it, so that's going to slow it down a little bit. And so what we had was we had a conical a volumetric flask, and that had 1.5 grams of oxalic acid and 250 mils. And so what you then did was you got sodium hydroxide. You got 25 mils of sodium hydroxide, and that was 0.01 molar. 0.1 molar, and eventually you worked out that it took 28 centimeters cubed of oxalic acid to neutralize that. Okay, and you did that in your conical flask. And so let's go to the conical flask. And so the number of moles of NaOH that you were neutralizing, concentration equals number of moles on volume, so it's T times V, and so it's 0.1 times 0.025. And so what you were neutralizing was 0.0025 moles of NaOH. Okay, and so the ratio is 1 mole of oxalic acid is to 2 moles of sodium hydroxide. And so how many moles of oxalic acid did you have in that that 28 mils? You had X is to 0.0025, and so we cross multiply, solves all our problems, and so 2x is to 0.0025, so x equals 0.00125 divided by 2 moles of oxalic acid. So that's how many moles of oxalic acid were in the 28 mils. And so you want to know what the concentration of the oxalic acid was in that 28 mils. Okay, and so the concentration in that 28 mils is concentration is number of moles on volume, and so it's 0.00125 moles divided by 0.028 decimeters cubed, and that gets you 0.00125 divided by 0.028 gets you 0.04464 moles per decimeters cubed. So that's the concentration of that. So what is the concentration? What is the total number of moles in the original, which is 250 centimeters cubed? Okay, so what you have here is that there. So the number of moles for the volumetric flask, the number of mole concentration is number of moles on volume. So number of moles is concentration times volume, and so that's 0.04464 molar times 0.25 decimeters cubed. And so divide that by 4. I'm just literally going to divide that by 4 because it's by 2.5. So that's 0.1116 moles of oxalic acid. All right, and now we need to know the mass of the oxalic acid in the volumetric flask. And now what we did with the 1.5 grams was the oxalic acid plus the water. So that's how we're going to get the amount of water on it. So the mass of the oxalic acid is number of moles times molar mass, and so the molar mass, number of moles is 0.01116 times the molar mass of oxalic acid. Now that is COOH times 2, so that's 12, 16, and 1. So that adds up, is that 12? 32 to 2 oxygens and 1. And so that's 13 plus 32, which is 45, times 2 is 90, so it's 90 grams per mole. Alright, so 90 grams per mole, 0.016, I'll times that by 90, and that gets me 1.004 grams of oxalic acid. So the amount of the mass of water in the original is, so the mass of water is the 1.5 grams minus the 1.004 grams. Alright, and so I minus 1.5 and I'll get 0.4955 grams of H2O, which is, so that's how much of that original 1.5 grams of oxalic acid was actually just water and not oxalic acid. And so the number of moles of that H2O is mass on molar mass, so that's ditto on 18, and so I'll divide that by 18 now, 18, and so that gives me 0.0275 moles of H2O. Alright, so now the last thing to do, if you're still alive here, is to do the empirical formula on that. So the oxalic acid, we've worked out the number of moles of oxalic acid is that there. It was 0.01116, and the H2O was 0.0275. So the smaller one is this, and so we divide both sides by 0.0116, and so that divided by 0.0116, and that gets us 2.4. I don't know if that's correct or not, but there we go. 2.4. Alright, and so the answer is, let's write out the full answer, COOH with a little 2 there, that's oxalic acid. So the final answer is, I'm going to convert that down, COOH, alright, with a 2, and it's 2.4 H2Os. Okay, now the correct answer is 2. Alright, and so that's our final answer. It's good to explain why, so I just want to do that as well. So we overshot on that because we ran out of time, because we found we were using the wrong concentration. I thought I could get away with 0.5, but then we worked out we didn't have enough solution when we need 5 times the amount of the other solution, and I found the bottle just mixed in with other stuff because I was doing lots of other experiments previous to that, the previous lesson. And so if that's if we've overshot, then that's too large. And so let's go back to our original calculations. You need to do this for your error analysis and possibly in your exam as well. So you need to know where the errors are occurring. Should have we got more or less? Does that make sense? And so that was the clearest error. And so where is that 2.28 to come up? Where's the 28 mils? So that's that there. It should have occurred. Oh, I've made a mistake. Have I? 28 mils. Oh, here it is. Here it is. All right. So if this value is too large, which is what happens when you overshoot, so that's too large. That's going to make that too small. And if that's too small, then this is going to be too small. And if that's too small, this is going to be too small. And then that'll be too small, and then that'll be too small, and then that'll be too large, and so that'll be too large, and so if that's too large, that'll be too large, and then that'll be too large. And by the way, that 0.0116 is too small as well. So there's a double whammy with your errors. And so overshoot usually is by a mil, and so that would be at least 3%. And so there's a double whammy here. So you might have made your errors about 6%. And that's probably accounting for most of the error in this, making this slightly too large. Alright, so the effect of overshooting and getting too much using up too much oxalic acid is to increase the number of waters. Alright, so it's a little complicated. It's easy just to draw arrows through it. Okay, so I hope that helped.